video, I'm going to explain about register addressing mode, immediate addressing mode, and direct addressing mode. Three different addressing modes I'm going to discuss in this video. So we know that inside the CPU we are having ALU, control unit, and then some set of general purpose registers R1, R2, R3, like that, up to some n number of registers will be there. Okay, this one. Now what this are done, so and then we also know that, so we are having sort main memory, so okay, main memory, and we know that this main memory is divided into what? Blocks, okay. That means, so here, so I'm having so many blocks. In one block, assume I'm storing one word, okay, because in one other video I explained that word addressability, okay, byte addressability, and one word is equal to combination of 4 bytes, okay, 1 byte. Suppose this is the address of 0, okay, so that means this location is having 4 byte, means 0, 1, 2, 3, 4 bytes. So next is 4, next is 8, next is 12, like that. Assume this byte address starts from 1000. Okay, so now assume this, okay, this word address is, for example, say 2750, this byte word address. Assume this word address is 3910, for example. This is the 5000 address. Okay, so this is some main memory. Now we know that what variables are nothing but the names given to these memory locations. Okay, let us assume I have given the memory location something, let's say this is what A and this is say B. Okay, for example, that means now the A is nothing but the name given to this address of this location, and B is the address name given to this address of this location. Now assume I want to do addition operation on two numbers. Let us take 12 plus I want to do some 18. This is the two numbers I need to add. Now how to add in register addressing mode? See, in order to perform addition operation, what is the opcode we have to use? The opcode what you have to use is add. Okay, this is the opcode, that means operation code to perform the addition operation add, and then the two operands. Now what I have to add? So whatever the value I want to add, that I am storing in registers. See, here I am storing. Let us take in R1 and R2 I am storing. Okay, 12 I am storing in R1 and 18 I am storing in R2. So what I can write here? Add R1 comma R2. Now what it will do? It will add the content of R1 with the content of R2 and store the result back in R2. The meaning of this is, it will R1 plus R2 it will add, and the result is stored back in R2. Okay, now here what is the operand I need to add? These are the two operands. The two operands, if you store in the register, then that addressing mode is called register addressing mode. Very simple. So summary, in register addressing mode, operands are stored only in the registers. That's it. We are not using anything. Okay. So in simple, only one line. In register addressing modes, operands, whatever we need to do the operation on any values or the variables, that operands I am storing in the registers. That's it. Okay. This is simple register addressing mode. But sometimes I want to add expressions like this, something. Okay. I don't know what value is it. What value? Suppose I want to say, I want to add B plus, say for example 6. That means here one variable, I don't know what is the value stored in variable B, and some constant I have to add. At that time, it is not possible to use what? Register addressing mode. At that time, I should go for what? Immediate addressing mode. Okay, at that time I should go to what? Immediate addressing mode. Okay. In immediate addressing mode, what we'll do? So same thing. Assume in B I am storing, say, let us say for example 13 I need to store, the 13 I need to add with the value 6. So now what I will do? So same thing, now again I have to add. So for this add, first one C. So if I write 6, see, if I write the 6, see 0, 1, 2, 3, 4, 5, 6. 6 may be the address also, or 6 may be the value also. How to differentiate between the address and the operand? So for that, in order to differentiate between the address and as well as the value. So we are using the hash symbol to indicate this is the value, not the address. Because 6 may be the address also, 6 may be the value also. For example, see, suppose if it's 1000 may be the number also, or it may be the address also. So in order to differentiate between the addresses and the actual numbers on which we want to do some operations, we are using hash symbol to indicate the numbers, okay, that operands values. So that I'm adding with what? B value. Okay, so now the meaning of this is, so whatever the value of the 6 will be added with what? B. In B, what is around 13, and the result is stored back in B. Okay, so this result being stored back in B, so 19. Okay, this is called immediate. That means here, our processor no need to go anywhere. The one of the operand is available in the instruction immediately. No need to go anywhere. But here in this case, it is to go to what registers? CPU has to go to register, take the value. But here it is not going anywhere. See B, for that CPU has to go to this memory location, take the value. But here this operand, especially this operand, is available immediately in the instruction. No need to go anywhere. Hence the name called immediate addressing mode. Okay, so now this is one example. So now another example. Suppose let us take again same thing. I want to add the two numbers. Let us take 12 and another one is 18. I want to add these two, 12 and 18. And I stored 12 in the location 5000 address, and that address I am giving the name B, and 18 value is stored in the address 2750, and for that I have given the name A. This is okay, variable name. So this is the A and B are the variable names given to some addresses. Now see, this is again straightforward. How to do that now? Say add what? A comma B. So the meaning of this is what? So this meaning is straightforward again. So here it will add the content of A with the content of B. The result is stored back in B. So that is 12 plus 18, 13. So 30, that will be stored back in the B. Now this addressing mode, it is called as what? Direct addressing mode. It is called direct addressing mode. Why it is called direct addressing mode? See, whenever we take the variable name, this is the name given to this address. So this variable names is replaced by the addresses. So whenever the CPU comes to this instruction, so it will now add on what? A and B. A means what? The address. See, A gives the address. Address is what? 2050. Go 2050, takes the value. And B means its address. That means addresses are given directly in the instruction. So that CPU go directly to the what? To the memory location, that particular location, take the value to that operation. So hence it is called direct addressing mode. Okay. So when to use which one? Whenever you are using some constants in your expressions, at that time we go for immediate addressing mode. So when we are dealing with normal variables like local variables or maybe the global variables or normal variables when we are using, at that time we go for direct addressing mode. Okay, so but generally we don't go. So among all the addressing modes, because in the last video I explained there are 10 different addressing modes. Out of all 10 addressing modes, this register addressing mode is the fastest addressing mode because the registers are stored within the CPU. And hardly we are having 16 registers or 32 registers. Hardly we are having what? 16 or 32. Suppose if I have 16 registers, to identify 16 registers, I need only what? 4 bits. 4 bits is enough to identify. Suppose if I use 32 registers are there. 32 registers are there in my CPU, then hardly I need 5 bits. But in your main memory addresses, these addresses are requires 32 bit. If it is your memory is what? 32 bit. If your memory is 4 GB. If your memory is 8 GB RAM. If you are using 8 GB RAM, then it requires 33 bits. That means this address is written 33 bits. How do you in a decimal? In binary it is written in 33 bits. So searching 33 bits is easy, or only 4 or 5 bits is very easy access registers. So register addressing modes are the fastest addressing mode when compared to all others. Okay. So hope you people have understood this. If you have any questions, please write it in the comments. Thank you. Thanks for watching.